Okay, today is 7.2, day 2, and we're going to be introducing different kinds of triangles. So far we've only looked at the right triangle. So today we're going to look at the isosceles triangle, scalene triangle, and equilateral triangle. You must remember the difference between all three of these. The isosceles triangle has two sides congruent, and from here on out you need to know that if I use the word congruent, and you can as well if you need to use that word, you can use the following symbol. That means congruent. So two sides congruent is an equilateral triangle. So if I look down below, this has one mark on it and this also has one mark. So that means those two legs are congruent. So since those two legs are marked congruent, this is an example of an isosceles triangle. And I need to make sure I spell that correctly. There we go. Okay, a scalene triangle has no sides congruent. So if I look down below, this side has one mark, this side has two, this side has three marks. So all three of those are marked differently. That means they are not congruent. So this is our scalene triangle. Our last type of triangle then is the equilateral triangle, and equilateral triangle means all sides congruent. So if I look at the example given to us, all sides are marked congruent with one mark, so that means this is our equilateral triangle. Okay, so now that we know those types and that vocabulary part, we can put this to work. So it says Randy plots the points A is at 0, 5, B at 7, 1, and C at 4, negative 2 on a coordinate plane. He joins the 3 points to form a triangle ABC. Find the lengths of the three sides is triangle ABC, an isosceles triangle, and explain. So the other day we did that and we had to use Pythagorean theorem. Today I'm giving you the shortcut, and that shortcut is known as the distance formula. The distance formula is the square root of x minus x, and it's the quantity of x minus x squared, so it's in parentheses, plus the quantity y minus y squared. That's our distance formula. So I'm going to go ahead and I'm going to graph these points, and I'm going to change color so hopefully it will show up a little bit easier. We'll change to pink here. A is at 0, 5. So I don't go left or right at all. I go up 5. And I'm going to mark that as A. B is at 7, 1. And C is at 4, negative 2. Okay, and I'm going to try to connect this using this tool. Let's see if I can get it to work. Oh, it's on white. So let me change that color. Hold on here. We'll get this figured out. Let's try this. A connects to C, A to B, and B to C. If I look there, that's correct. I just lost my C here though, so we'll label that as C. So basically it wants us to find the lengths of the three sides. My three sides, AB, segment AB is a side, segment AC is a side, and segment CB is a side. And those are in no certain order. Those are just the three sides. So I can use my distance formula to find those lengths. So what I do is I write down my coordinates. A is at 0, 5. B is at 7, 1. So now I plug them into my formula. So it's the square root of, and I just use the order they're in. So x minus x means 0 minus 7. Parentheses squared plus the quantity y, and remember you have to do it in the same order. So this one was first, so 5 minus 1 squared. Okay, that gives me the square root of 65, which is approximately 8.1. So AB is approximately 8.1 units long. AC then, A is still at 0, 5. C is at 4, negative 2. So I have the square root of 0 minus 4 squared plus y minus a negative 2, so be careful there, squared. What I do to get this exact, I just put everything inside the square root symbol in my calculator, and it will simplify it for me to the square root of 18. And then I put the square root of 18 in my calculator to get the approximate value, and the approximate value, oops, I totally messed up on that, erase that. Probably wondering what I'm doing there. So AC would be approximately 65, or exactly 6 square root of 65, which is approximately 8.1. If I notice something, those are the same. So it's telling me something there. And we'll talk about that in just a minute. The next one is CB, which I just tried to do. CB, so I have C is at 4, negative 2, and B is at 7, 1. So I do the square root of x minus x, so 4 minus 7 squared, plus y minus y, which is negative 2 minus 1 squared. To get my exact, I just put the inside part into my calculator, and it gives me that this is exactly 18, square root of 18. Put that in my calculator, and it tells me it's approximately 4.2 units. If I look over there, it makes sense that this is a smaller number because in my drawing it does appear smaller. Okay, after I find the lengths of the three sides, it says, is it an isosceles triangle, and explain. Remember, we noticed that these two were the same, so isosceles means at least two sides the same. So this would be, is it an isosceles triangle? Yes, because side AB is congruent to side AC. And we're done. It's a little faster than yesterday, drawing all the extra triangles and finding the lengths. So that's your distance formula. Just make sure you have them. Whatever x you put first, that's the y you put first. Okay, so your practice then is guided practice page 25, number 2. And assignment then is page 28 through 30, 3 through 9.